Hello everyone. Today we are going to see this problem, trimming a binary tree. So let's go over the question. Given the root of a binary search tree and the lowest and highest boundaries as low and high, trim the tree so that all its elements lies in low and high. Trimming the tree should not change the relative structure of the elements that will remain in the tree. That is, any node's descendant should remain a descendant. It can be proven that there is a unique answer. Return the root of the trimmed binary search tree. Note that the root may change depending on the given bounds. Let's go over the example. So you have the root 1 and left node as 0, right node as 2, and the low and high is given as 1 and 2. So what it means is like your node should contain only 1 and 2 in that range, and anything below 1 or over 2, it should not be shown in the output. So in this case 0 is a node which is less than 1, so it is not part of the resulting output. The example 2, 3 is the root, 0 is the left node, 4 is the right node, and for 0 you have 2 as the right node and 1. So the range is given as 1 and 3. So anything between 1 and 3 will be shown in this output, and 0 is less than 1 and 4 is over 3, that will not be included. So 2 will be joined to 3 as the left node, and that's the output here. So let's take the example of 1, 0, 2 as the example 1, and we have the range as 1, 2. So this is low and this is high. So in our program we'll check whether this one is less than low, this root node. It is not. And we check whether this is greater than high. It is not. Then we recurse with left node, right? Here also we check whether this is less than low. Yes, it is lesser than low. So in that case what we do is we completely omit this and go to the root dot right. So in this case the root dot right is null. So when the root dot right is null, we return back and we go above, and in this case we check that this particular 0 is not included, so we go to root dot right. So in this case here also we check whether this value is lesser than low or greater than high. So yes, it is in range, so we will include that in our recursion as root dot right equal to the actual recursion of this particular flow. So that is how we get to add this, and at last we will return the root value. So let's take another example of 3, 0, 4, nothing there, so 2 and 1, right? So here we check the range is in 1 to 3. So is this in range? Yes, this is in range, so we include that. Go here, this is not in range, we'll go to the right value. So here this is in range, we include that, and we go regularly and we go to left. Left is null, and no, left is 1, so here we include that 1 also through the recursion, and we go back and we check the right. Right is not there, we go back and so since 0 is not there, we'll go back to 3 and see if 4 can be included. In this one 4 cannot be included, so this will be connected to 3, so the final option will be since we are pointing root dot left as the output of 0 for 3, so 3 root dot left will be assigned to 2, so the output will be 2 and 1. So let's start to solve this problem. If so first the base case is equal to null, return null, and after that what we do is we check if root dot val is less than low. So in that case what we have to return is trim bst of we are completely omitting the left part of it, so we are going over right side and just pass in right. And for the same condition, if root dot val is greater than high, so that means we are omitting the right section and we are going towards recursing on the left side. So here there is a okay, so then after that we assign left is equal to trim bst of root dot right, root dot left, low and high, root dot right is equal to trim bst of root dot right, comma low and high, and we return the root at last. So just go over the sample case. It goes off and running gives this one. Okay, thank you.